capabilities on research within the Microsoft Azure platform. I've got with me Mark McManus, who's the UK Cloud Education Lead. Mark, can you say hello? Just do a sound check and make sure we can all hear you okay?
Good morning, everybody. Thank you very much for attending. Can you hear me, Joe?
Yeah, that's perfect. Nice and loud and clear. Great stuff. So yeah, I think the purpose for today's session really is to showcase some of the capabilities around the Azure platform and talk about some use cases of where we've got this off the ground. We've been, ANS personally, we've been doing this around a number of universities. We're starting to see big interest in it, and actually there's some very good use cases where Azure can deliver capabilities where other platforms start. So I'm not looking to steal any of your thunder, Mark. I'll hand over to you and let you take the guys through it.
Thank you very much, and I really appreciate you, Joe, and ANS for putting this together and being able to speak to you all. So thank you for taking some time out of your day, and hopefully it's not too cold out there. We're kind of iced up where we are, so it's nice to be inside and warm. I'm Mark McManus, as some of you may know. I'm the Cloud Education Lead, as Joe mentioned. I work with universities, colleges, councils in terms of the move to the cloud and using cloud services from the Microsoft portfolio, if you like. And in going around speaking to academic science universities specifically, what we've found is some interesting challenges in terms of typically central IT providing resources to the research community. So many universities have research capabilities and are looking to extend those capabilities, and in providing a better service to the research community, and of course improving revenue flows from research and increasing budgets from research grants, etc. Some of the challenges we've come across specifically is central IT trying to service the research community when typically their approach may be not as sort of well planned or well thought out as perhaps other IT services, in that research is very focused on securing research budgets or central research services, etc. And then typically IT becomes a secondary priority. Not to say that it isn't a key focus. It obviously is for the researchers in question. But what we find is, in talking to central IT services, CIOs, etc., is that researchers tend to have short notice requests, and the central IT find it very difficult to provision those requests in a timely manner. Typically, if a researcher for instance, I was at a university recently where they'd taken delivery of some electron microscopes, and they realized that the actual storage requirement for those microscopes were significantly larger than they'd originally planned, and so there was a request to central IT for a provision of several petabytes of data storage, and they simply didn't have that capacity within the service that they're running. Of course, central IT running IT services, line of business applications, storage across the university. So being able to spin up that level of storage with such short notice just wasn't within the capacity that they had. And so typically what we find, again, lots and lots of examples of that kind of approach where there's perhaps arguably a little bit of a mismatch between what central IT can deliver and what research teams are needing. And so what typically happens, as we understand it, is that researchers will then go out, they'll procure using their own research grant, their own research budget, and then they'll build their own IT environment. And that might be absolutely appropriate to do that. However, what tends to happen is that the IT services typically built by the researchers doesn't necessarily adhere to university governance, to university compliance, backup, failover, etc. And so then there's a bit of a challenge if something goes wrong. And so these are some of the issues that we're seeing when we speak to researchers. Now, we've been working with researchers from an Azure perspective for over 3 years now, and that's predominantly being led out of Microsoft Research in Cambridge. And if anybody knows the lead there, Kenji Takeda, who used to work for Southampton University. He's been leading with that initiative, and typically he'll work with researchers directly, with research teams, associations, groups, etc. And we've been able to do some wonderful examples of using Azure in research. Again, one of the challenges in that, we've been approached by some CIOs recently to say, well, actually, Microsoft, with partners, we'd like you to work with us, Central IT, because what we want to do is to try to centralize that so that we can try and enhance the research capability, provide a governance and a compliance structure for research environments, and in a lot of cases centralize that budget where possible so that economies of scale can be realized. So what we kind of sat down, had a think about this as to, well, what could be a good approach? So rather than working directly with researchers, research groups, etc., how can we work with, through our partners, work like ANS, work with Central IT to provide a research environment that can help Central IT provision research requirements. And so this is based on this presentation. And where we've presented this with the ANS, it's had extremely positive resonance. So hopefully, as we go through it, you can see the positives in doing that. So moving on slightly. So as I say, some of the customer challenges, interestingly, when we speak to senior IT management in universities, typically they'll say that less than 50% of the IT budget of the whole university is actually channeled through Central IT services. The rest is fragmented through academics, departments, and research, centrally funded research environments. And again, as I said before, there might be genuine reasons, and it might be highly appropriate to do that. But typically what we find is certainly the finance officers and the CIOs are keen to try to channel that through Central IT. So again, to realize those economies of scale. So if we could provide a service to do that, especially for research, then of course we can then hopefully look at reducing costs, increasing the efficiency, and less time on procurement. And that's less time on procurement for the researchers. So one of the benefits of providing a central research environment for researchers will be to take away that time from researchers that they have to spend on procuring their own environments. And that means hopefully that they can get on with research quicker rather than going through procurement processes. Again, looking at those customer challenges, requests from academics and researchers can take 3 to 6 months to procure and deploy. And in some cases a lot longer, depending on the complexity of the environment being requested by research. Ideally, what we want is on-demand self-service environment, centrally managed, centrally organized with compliance, with governance wrapped around it, but being able to spin up environments really, really quickly with virtually unlimited capacity. And of course, that benefits Central IT in terms of servicing the research environment with that sort of governance wrap around it, but also still maintaining the autonomous approach that the researchers would require for the environments that they build. Just reinforcing that, the research and academic IT departments, the environments, they typically do lack governance. Again, this is not from Microsoft, this is feedback that we've had from universities that they're working with. Obviously, if a centrally managed service would have that compliance, that governance wrap around it, regardless of the environment that you're providing to the researcher or the research group. Again, trying to reduce the time in trying to build these environments. So for researchers, so again, using a central IT service and an on-demand service, it means that researchers can get on with their research quicker. And of course, that means faster publication, a more agile research environment, which of course in turn enhances the researcher's capability for more research grants being able to go out and, of course, ultimately enhancing the university's reputation. And then the other, finally there, again, based on feedback that we've had from universities we work with, researchers often need short-term access to expensive research environments. whether that's high-performance compute environments, whether it's high-end workstations, analytics, whatever it may be. And of course, if that's been trying to service that locally, one, you have to have the capacity to do that. And of course, if you don't, then procurement is the only option to go out and build that environment locally. And of course, that means a capex upfront expenditure to do that. Whereas if we could provide a centralized service based on cloud, public cloud services, then there's no upfront capex requirement. You're only charged for what you actually use. So research funding can be held against cost codes until required. And so that means that the actual environment becomes much more agile. What do I mean by that? It means that if you start off with a research project with a certain build, a certain set of equipment, IT equipment, then typically throughout the longer the project, typically the requirements change. And if you haven't got that up front, then that means more expenditure to pay for an environment. Whereas in public cloud, it's simply a case of switching the resources around and not affecting the underlying. There's no wasted investment in that case. So these are some of the addressing some of those research challenges that we see when we're talking around. And of course, what we're talking here is using public cloud. And in Microsoft's example, it's using Azure services, which is our platform for providing infrastructure as a service, platform as a service, and all the services that we have built into that environment. And so, again, looking at some of those challenges, research constrained by resources, there's only so much capacity that a university has on premise. Virtually, you have unlimited resources in open cloud, in public cloud, and more resources being added literally by the day, it seems, to provide more resources and services. And that means, of course, that getting access to newer, better environments may enhance a research capability. It also means, I was speaking to a university yesterday about some high-end services required for astronomy, and that the burst capability and the fact that they couldn't provide the scale that they needed for short-term high-end requirements, and talking about using cloud to be able to service that need, so that when required, subject to, of course, the cost of it, I can burst out and perhaps cut down a workload from running for months and months and months to a matter of weeks, because I can spread that and push the resource capability into the open, into the cloud platform, providing with virtually unlimited resources. Time to provision new resources, well, we can go from 3 to 6 months in terms of procuring to literally minutes. Given the key to public cloud, as you may all be aware, is automation, scripting, and templating. And so if I have a templated, automated environment, I can literally spin up a large Hadoop environment, high-performance compute environment, in literally 10, 15, 20 minutes, depending on the size and complexity of the service. And so compare that to months in terms of building an environment. So again, the key then becomes the innovation, the research itself, and getting the publication done. So imagine the time difference in being able to spin up something immediately. For central IT, it means that you can say yes to research. So rather than saying, well, no, we can't do that immediately, or we don't have the capability, you can say yes. And you can spin up that environment, or have the researchers spin up their own environment within an autonomous area for their research requirements that they need. And so it changes the whole relationship and dynamic between researchers and central IT. The other issue there, expensive or not possible to scale. Again, looking at local resources. Again, we can best on demand. So we're talking to several universities at the moment who have their own HPC and spend significant amounts per year on their own high-performance compute environment. But typically what they find is that the queue during certain times of the year gets so long that it becomes very restrictive. And so what we're looking at is bursting out some of that capability to cloud to reduce that queue to hours rather than days or weeks in terms of queuing for the high-performance compute environment. And this is where we feel we have an edge on our competitors, simply because of where we've come from. We have built an awful lot and invested an awful lot in hybrid, in mixing on-premise environments with cloud environments. So that burst capability becomes very easy and seamless to use in terms of the researchers being able to burst from on-premise into cloud and then back again when the demand has finished. Talking to several universities about rendering, for instance. So the next issue there was workstation bottleneck. Talking to one university where most of their key workstations, high-end workstations, can be tied up for days for video rendering, where they're doing specialist work on videos. And so I can offload that into the cloud, freeing up the workstations locally for other classes, for other workloads, etc. So again, I can build powerful workstations in the cloud, run them up when I need them, drop them when I don't. Sharing, obviously, with publicly funded research, the results, the data results, have to be publicly available, and so there's a lot of effort at the moment for universities sharing that data and being able to share that data. Well, if that's on locally built departmental services, it becomes tricky to be able to share that information. If it's built into the cloud, I can add a module to it. When the research has finished, when the results are available, I can make that publicly available very easily. And so it fosters more collaboration, sharing, and then more focus on the publications of the final results in a quicker way. Again, related to providing hardware on-premise, obviously, any CapEx investment, whilst there will be a focus on getting the latest equipment, obviously that will get outdated the longer the project goes on, and therefore you're tied to that older hardware unless you make a new investment. In cloud terms, you can switch around to different workstations, different machines, different workloads as they become available. So if new technology becomes available, a new service becomes available that's more appropriate for a research project, then you can simply switch to that new resource. Again, enhancing the research and hopefully bringing you to more conclusions quicker. And then the environmental impact, obviously the more hardware you buy, there's an environmental impact. There's a lot of focus in the universities about being carbon or reducing carbon footprint. Microsoft has had a commitment since 2012 to be carbon neutral. So everything that we do use in terms of power, we offset. So since 2012, we've had a completely carbon neutral, regardless of the fact that we've got huge data centers around the world, 40 areas around the world now, 42 soon to be up and running, that use significant amounts of power. Of course, offloading that to Microsoft helps the university with its carbon footprint and its green agenda. So that's a key focus. So let's just quickly just go and have a look at how this would look in terms of managing, because for those of you perhaps running Azure already, and there's 65 universities in the country now running Azure, either tactically or strategically, but that's typically for line of business applications, it's typically for addressing student requirements, etc. We do have some, as I said, using Azure for research and good examples thereof. But it's bringing the two together. How would we provide a management environment to do that? So those of you familiar with Azure will recognize this. In terms of managing your Azure structure, there's 4 key environments. So at the top end is the enterprise, there's top departmental, there's account level, and then there's the subscriptions themselves. So at the enterprise level, that could be the university itself, or it could be set up as central IT services. In terms of these boxes that are coming up on your screen, central IT services, line of business production, you can decide how to structure this. You can decide what they're named and how they're structured. This is just an example from one of the universities that we've worked with, where they set up at the enterprise level central IT services that manage the entire Azure estate and environment. They have a departmental level, the line of business production environment, which in turn is broken down into development and testing, staging, and the actual data center extension. So they've extended their data center into the cloud, making it seamless. So they have their environment in the cloud as though it's as part of their data center, an extension of the data center in the cloud. And then underneath that, you have the subscriptions or the relevant Azure resources, whether that's virtual machines, data storage, analytics, artificial intelligence, whatever it may be. Those resources assigned to those accounts in line, assigned to that departmental level. So if we have that structure in place, if you have that, you may have that already in your university, what we can do is apply the same structure to research. So simply at the departmental level, having a research environment, which in turn is broken down at the accounts level into individual researchers, research groups, academic departments. Now we're working with one university where at the research level they prefer to have colleges, so separate colleges at that level rather than an overall research departmental group. They've decided to break that down into independent colleges with associated researchers, research groups, and academic departments associated with each college. You can structure it the way you want. The point being here that the overall Azure environment provides a structure and a management, auditing, and even financial review across your research environment as well, where you can manage resources down to an individual researcher level. And so this makes it extremely flexible in terms of providing resources to, as I say, individuals, groups, academic departments, and colleges. We've done a similar structure for the Turing Institute, where we've got individual PhD students with their own environments, and so we've got a great comment as a case study that single PhD student, got her own HPC environment. So she has a small high-performance compute environment just for her. And her quote was, "I have my own HPC environment. There's no queues. I don't have to be forced off it for somebody waiting behind me. It's my own environment." And again, it's up to you as to how this is structured and how you can use it. But the idea is that you have this flexible way of managing individuals, departments, groups, up to central IT services level. And that means you can, of course, apply compliance, you can apply backup failover to these environments as part of your templated structure, and of course, as part of your automation. So it makes it very easy, once this is in place, to spin up virtually whatever you want within these environments and give that access to the students, the PhD students, the researchers themselves. And of course, potentially add third parties, whether that's commercial third parties or other universities who are working on the same research environment. But this is a great way to manage that. Those of you, again, who understand Azure, you can have delegated access to these individual resources with managers, and maybe at the top end level, the central IT services level, you can also have somebody who reviews the funding and where's it's going. So to know exactly what each researcher is spending, what each research group is spending, is very valuable in terms of feeding that back to the research team and understanding the requirements ongoing. So in terms of the overall approach, again, key value propositions, we've talked about these before, but one of the key elements is being able to provide open source environment. Perhaps because of Microsoft's past, often called the evil empire, etc., in terms of services that are only provided by Microsoft. Microsoft has made a huge investment in ensuring that the platform is ready for open source. And in fact, over 40% of the services worldwide on Azure are open source environments. Whether that's Linux in terms of the virtual machines, whether it's Hadoop in terms of data storage, etc., etc. There's a whole range of services for open source, and Microsoft heavily committed to contributing to those environments, and do contribute to those environments. So that means that we can open up the platform other than Microsoft environments, which is of key importance to the researchers themselves. From your perspective, central IT, on demand, you can provide that for the university's level. Governance is built in, but you can provide an autonomous environment, as you said, based on that structure you can provide that autonomous environment to the researchers themselves. So you're getting the best of both worlds. Researchers have an environment that they can build what they want in if you allow them to do so, but you've still got that overall control in terms of governance and compliance, as we've mentioned before. And the key to cloud is automation, having those templates, those automations for typical builds in place, and of course ongoing maintenance and adding to that automated environment. So what's the engagement plan in terms of this structure? So working with A&S, we would present the idea to senior leadership team in the university, and we get one of the key aspects to the approach is having a contact in IT services who looks after research. So either that's an individual or a team of who look after research requirements and requests. And the idea is that that team, the contact in those teams, are up to date with new services from Azure, what's going on in Azure, and services that can be used, automation, templates, etc., so that they can help translate what the researchers require for their research project into the actual services in Azure. One of the other requests in terms of best practice is also to have a sponsor in the research side, so somebody as authoritative as possible in the research side of things as a sponsor for the central services environment, again to help with that translation, to sponsor workshops, and to encourage use of the central IT environment rather than researchers going out and procuring their own. We then assess typical research requirements of the university. What are the typical bills? And I know there's a wide and varied range, but typically we can get down to some basic bills that we can add for automation, scripting, templating, etc. We plan a proof of concept engagement, and we target some initial workloads and work with some researchers who have workloads that we can put into the cloud. We deploy the research environment based on that structure you saw before, and then we'll train the IT staffs on that, on how to manage that environment down to individual researcher level, and how to automate and template the environments, etc. Review the proof of concept, and then we'll deliver workshops for researchers as a collection. So again, using the researcher sponsor, we can take the concept to the researchers themselves, help them understand what Azure is, how it can be used in research, how it is being used in research, and some hands-on in terms of what they would use, spinning up workstations, Hadoop environments, data storage, whatever it may be, and working on those workshops to encourage the researchers to use the central IT services that's being set up. Ongoing commitment in terms of engagement and support. What we started is creating a research community. So the idea would be we'd host monthly research-focused webinars, quarterly training. We're setting up a yearly conference specifically for research, and that would include engagement with Microsoft Research as well. So we're sharing ideas, concepts, best practice, and how to use these environments. Some of the targeted solutions, well, again, mentioned open source. Open source is absolutely key to research in terms of the services that are being used. And as you can see there, a whole plethora of resource and more than that in terms of open source environments that can be run in Azure. I'll go through them all in interest of time. Often we're getting asked, well, seriously, can you run high-performance computing in the cloud? Well, yes, you can. Given the investments we've made and the partnerships we have with the likes of NVIDIA and others, it's providing InfiniBand networking between the services. Again, automation is key here in terms of being able to spin up a true high-performance compute environment attached with storage, etc. So yes, that is absolutely possible, and we have researchers using that type environment. So it is absolutely real in terms of doing that. And we can go through some of the examples of this. We did some benchmarking in terms of comparing high-performance compute in the cloud compared to on-premise. Now, for those universities who don't have your own high-performance compute environment, or have a smaller high-performance compute environment, we can help you give literally like for like and more in terms of capacity, virtually unlimited capacity, access to that type of in-cloud environment, and compare that to the larger universities who have their own HPC environments. We can virtually give you like for like. So it does open up the potential for responding to more research requests and tenders. So some of the HPC solutions that we have, there's the hybrid cluster, there's the cluster on the cloud itself, the scientific workstations, and application-based or app-based with batch. And again, the key here is understanding automation and how to spin this up really, really quickly. And typically there we've got a table of the types of personas versus the typical solution that those individuals would need, whether it's individual researcher scientist to a central IT group lead, and the type of services that we would expect them to use in terms of high performance compute. So looking at these, this is an example, and again we've got good examples, case studies of people using this, where you've got an on-premise high-performance compute with a scheduling service in front of it, where I can actually take that and burst it into cloud. So, or whether that would be to reduce the queue waiting for the high-performance on-premise compute environment, or as I say, actually burst out an application that's coming to the capacity on-premise. So based on parameters, I can then spin up or have it preempted, ready to go in the cloud, given the workloads to address some of the heavier workloads that could run for months in some circumstances, which would increase the queue waiting for the high-performance compute environment on-premise. So this gives us a burst-out capability from your on-premises into the cloud. And again, the investments we've made in terms of hybrid, ensuring that works, is key to this. Cluster in the cloud itself, this is where we're actually running the whole thing in the cloud, the compute nodes, the head node, the data storage, etc., all running in the cloud based on scripting and schedulers all built in. And the Azure Batch, which is the Azure automation and scheduling service, is a free service. So obviously the underlying services themselves, the virtual machines, the compute nodes, etc., they are chargeable, but the actual scheduler itself and the automation service, Azure Batch, is free. And the key there at the end is you can deploy as many clusters as you need. And so we do have some universities where they're considering having a single high-performance compute environment in the cloud and having a scheduler to manage who uses it when. But the other concept is, well, actually I can spin up a cluster for an individual. So it might be absolutely appropriate for a certain research team, a group, depending on their timescales for the type of results they're trying to get, to spin up their own environment for a few days, a few weeks, a month, whatever, without knowing that they're going to have to give it up because there's a queue behind them. So again, that agility in terms of setting up that environment helps with the research, and the research is going to the conclusions quicker. Then we've got the scientific workstation, so we have a huge amount of services and virtual machines and templated environments. Ready to go with pre-built applications and services on them. So the Azure Marketplace has research workstations ready to go with relevant services, whether that's Linux environments and applications on top of that, ready to go. And again, so literally seconds or minutes to load them, use them as needed, drop them when you don't need them. And so, yeah, so we look at being able to have this huge scale. And so, again, it comes down to the innovation. It comes down to the research itself. The focus is that I can literally provide, we as ANS and Microsoft can provide this type of environment where we can spin up huge amounts of resource, 100 times the scale to what perhaps researchers are used to, so that result can come in days, weeks, rather than months or even years. And so having that kind of capacity and capability there gives a whole new perspective on their own research environments. Of course, it's not just high-performance compute. There's been amazing breakthroughs in enabling artificial intelligence, the data behind it, the algorithms, the cloud computing. We've provided modules. So again, these are as-a-service modules. So you don't have to build a workstation or an underlying infrastructure. They're there as a service. And so whether that's visual recognition, speech recognition, language translation, being able to search dynamically using machine learning, and setting up labs within the Azure environment, these are as-a-service environments. You don't have to build the underlying virtual machine or data environment. That's already done for you. And then finally, we now have a Microsoft Genomics service. So again, huge amounts of resources typically used on analysis of genome sequences, etc. So again, Microsoft have a genomes as a service built into the Azure environment, which can be of great use, obviously, certainly on the health side, if not the obviously biology, etc. So, in summary, the idea here, the approach is that we're helping central IT to provision and service the research community with a compliant and governed environment, but without taking away from the fact that they can have autonomous environments subject to resources, including funding, etc. Secure and compliant, so again, security is built in based on your framework, but on your policies, on your procedures, and of course that means if something goes wrong, that you can fix it, that you're involved in that environment, rather than being a research-only environment. It genuinely means faster research publications, because we're taking away all of that complexity and sort of arguably mundane processes of procuring and building stuff. It's allowing researchers to get on with the actual research itself, and so faster to research publications, which is a key advantage. And virtually immediate access. So rather than waiting months for something to be up and running, I can literally have it the day I ask for it, or if it's on demand as well. So thank you for your time. Really appreciate it. I hope that's been of interest. If there's anything particular, work with myself and ANS in terms of providing sort of perhaps more in-depth view of that and some of the technologies itself. Well, ANS and myself be happy to come to site to speak to you, good selves. But thank you very much for your time. Hand over to Joe now to wrap up and to host questions. Thank you.
Yeah, thanks for that, Mark. You know, that's certainly been hopefully really useful to everybody. In terms of any questions that you may have, there's a chat box in the bottom right-hand corner of your session. So feel free to open up any questions there, and both myself and Mark will be available, you know, as long as need be to help you respond to those questions. I guess, Mark, whilst the guys are all kind of putting some questions together, where would you say the best place to start is with this? Technically, is you know, where have you seen other universities kind of start on this journey? You may have lost Mark there. Okay, guys, so it doesn't look like there is any more questions. I'd like to thank you all again for joining. There'll be a recording of the session sent out, so if you'd like to share that with anybody, please feel free. And likewise, if you have any questions for both myself and the wider team at ANS, or directed at Mark at Microsoft, please feel free to email those to us as well. So thanks again for your time, everybody, and I hope it's been useful.